Mark, are you ready?
I sure am.
Awesome. And we have 4 people, actually 5, and it's probably gonna go up. Your session is very early, so not many people would like to learn about BigQuery so early, I guess. Well, welcome to the first virtual 2020 SQL Summer in Los Angeles. We have a presenter, Mark. He's going to be talking about Google BigQuery. If you have any questions, put them inside the chat, and Mark is going to stop at some point in his presentation. I'm going to voice out your questions, and please do ask questions. That's the only way that the presenter would know that you even follow his or her session. And thanks to our sponsors. Some of them you know, some of them you don't. O'Reilly and Wiley is publishers, so they're publishing books. AWS, obviously, and Microsoft are public cloud providers. Blackline is accounting in a cloud. Pure Storage is a company that provides storage. Cappuccino Insurance provides insurance. Gulfin Motors is where you can lease or buy your cars. And I forgot about SentryOne. SentryOne provides monitoring. This is specifically a room for VMware, and obviously everybody knows VMware is all about virtualizing your environment, and now they provide it from within the public cloud like Azure, GCP, and AWS. We have 5 South California local user groups: LA Data Platform, LA User Group, Orange County, San Diego, and Los Angeles in Korean. Please join your local group. This way you can get education every month. And in case of Korean, it's actually even more than that, more frequent. There's a handout section that you can see. It has some documents you can click, and it will show you how to reach the raffle or how to change rooms. And of course, the Past Summit. So same concept as SQL Server, except it's much larger, more rooms and more days. And now it's went virtual. Please consider to attend it, or virtually attend it, essentially. And you have 3 codes that you can use. Choose your preferred one. That just gives you, I think, $100 off or $150 off. I don't remember. So choose your user group that you want to be associated with. And with that, I think I'm going to change it to Mark. Hopefully I didn't, Mark, steal too much from your time.
No, you're all good.
Okay, and my becomes a presenter.
All right, got presenting. Well, good morning, everybody. Thanks for coming this morning. Unfortunately, we can't all be together in person today, which is generally the way that I prefer it, but hopefully it will be just as rewarding for you to do the talks virtually. And hopefully this is just the beginning of a great day. So without further ado, let's get started. So today I'll be talking about BigQuery, and specifically machine learning on BigQuery, which is pretty interesting as a new technology showing up on BigQuery. First, a little bit about myself. So I currently head technology for Safe Ride Health, which is a non-emergency medical transportation benefits administrator. So basically, it's a routing platform for non-emergency medical transport, and also ambulances and self-provided care and so on. So I've run workloads on AWS and GCP, kind of gone back and forth between the two and done both. I have a specific interest in BigQuery, and I have a book coming out about data warehousing with BigQuery later this year, hopefully. So you guys can check that out. A lot of what I'll be talking about today is covered there, as well as a bunch of other stuff. So first of all, what exactly is BigQuery machine learning? So first, let's talk a little bit about Google Cloud Platform. If you've seen any of my other talks, I'd like to give kind of an intro to the entire Google Cloud Platform. This will be focused today just specifically on BigQuery. So BigQuery is Google Cloud's offering for large data warehouses in the cloud. It started quite a few years ago now, but only recently, I think, has it been really starting to gain traction as it improves in performance and they start to offer a whole bunch of really competitive warehousing features. It's fully SQL compliant, so you can actually use regular SQL on it, which is pretty helpful when you're trying to do complicated stuff. And it just automatically will shard your queries and run them across multiple data centers, which is it's pretty fascinating how they actually do that. Like a lot of modern data warehouse providers, they separate the storage from the compute, so you can have large amounts of storage, but then the job that actually goes and retrieves your queries can be shuffled around across data centers. From a price perspective, as with most public cloud offerings, it's pay as you go. The free tier is pretty decent. You can actually do quite a lot on the free tier. Machine learning, as we'll see, is priced slightly differently. It's a little bit out of the regular scope, but it's still fairly competitive if you're going to do small workloads. So we'll be seeing everything we'll do today will be in the BigQuery UI itself. You can access BigQuery from the Cloud Console. You can also access it from the command line, and there's a full API. There are also SDKs for most major languages. So if you're using Python or Go or .NET or any of those things, you can access BigQuery that way. It's pretty straightforward to get started. So specifically, BQML, BigQuery ML, is a way to run machine learning models entirely within SQL. So the big breakthrough here is that the same SQL that you're using to do your queries, you can also use to train and predict from ML models, which is it's really cool. And you can also integrate that directly into your queries, as we'll see in the example later on. So it's pretty seamless. Up until now, and increasingly this is changing, but data science is usually sort of a separate thing that gets done by a data science team, typically in Python or R. There are a lot of great tools for doing that, but you have to be pretty familiar with the paradigm and what exactly you're trying to accomplish. And getting data in and out of those systems requires that you kind of understand both the data loading side and also how to do the code on the other side. So in BQML, you just stay entirely in SQL, which is pretty great. And the other thing you can do with it is you can actually share TensorFlow models from your data science team. So if you have a team that's already doing machine learning somewhere in your data stack, you can actually import those models directly into BQML and use them. So it starts to eliminate some of the bottlenecks that you experience when you're waiting for people to get back to you or run whatever model it was you wanted to run. So BQML went generally available just over a year ago, so it really hasn't been around that long yet, and it's fairly well supported at this moment. It supports a pretty good number of models, but it's, as with everything else in the BigQuery group, improving. So we'll go into supervised versus unsupervised models in a couple minutes here, but you can do a little bit of both. Another really great feature of BigQuery is that it comes with a whole bunch of public data sets that are built in that you can just query as if they were tables inside your own data warehouse. And there are a lot of public data sets around all kinds of public information, and there are sports scores and health stuff. There's a bunch of models that are specifically for ML training. So if you want a large data set to practice on, there are a whole bunch there too. You don't even need to try to figure out how to source those yourself. So that's pretty fun to explore. That being said, BigQuery is designed for huge data sets. And so it regularly, like a terabyte is not very much data as far as the BigQuery table is concerned. And performance has been improving steadily over the last few years. So you can actually get petabyte results in 6 or 7 seconds for optimized tables. It's pretty nuts. Of course, that's also where it gets expensive, but we'll go into the cost considerations in a minute as well. Are there any questions about BigQuery or Google Cloud Platform in general before we move into the ML specific stuff?
So far, I don't see any questions. Perhaps why would I choose GCP for machine learning and let's say not Azure or AWS?
Yeah, I mean, I think increasingly the clouds are pretty competitive. GCP had an early advantage because it did a whole bunch of integration with deep learning and the TensorFlow models. I think AWS and Azure are both pretty good choices now as well. And I'm less familiar with the ML offerings over there, but I know that there's a lot of comparable stuff. So I think one of the things that Google has been doing lately is improving its interoperability with other clouds. So you can actually federate data over to Amazon S3, and they're a little bit less responsive with Azure, but there are some other options there too. So it's starting to become an option to do data warehouse multi-cloud, which, you know, there are pros and cons to going hybrid, but it's definitely something that you could do.
Any chance of having a machine learning that you can copy paste from one cloud to another?
Yeah, I don't, that's a really interesting question. So you can export TensorFlow models from Python. You can also export them from BigQuery. So there are ways to transfer the model as a whole to another cloud. There are also things you can do around pulling the feature training that was done for the model. Like you can access all of the weights and everything that were generated by the GCP model, which would be more manual. Like you'd have to go and plug them in on the other side. But there's definitely some stuff you could do there. That's actually really interesting. I will learn more about that myself.
Got it. Thank you.
All right. So now I'm just going to kind of give an introduction to some machine learning concepts as they apply to BigQuery. So as I mentioned, you don't actually need to go real deep on this to be able to do some basic prediction models. But I've found that in training models and learning how some of this stuff works, that it's helpful to know some of the basics and as far as the statistics are concerned. So the term machine learning is actually from the 50s. It might even be earlier than artificial intelligence. It's around the same time. But the problem with all of these terms is that they become marketing buzzwords really quickly. And so you see people interchanging AI and ML, and you see people talking about how everything is machine learning, even when, you know, it's probably not, or the Amazon Mechanical Turk type stuff where it's really just like a person that is doing it and then they say it's machine learning. So it can be kind of hard to separate the actual practice from the terminology. Basically, machine learning is statistical learning, and it takes concepts from statistics in terms of how regressions and other types of statistical analyses are done, and then it just runs them across a giant number of variables. The big difference between statistics and machine learning is just machine learning is designed to be computationally intensive, and so it will run millions of coefficients and variables to get the right answer, whereas with statistics, you're a lot more concerned with the actual correlation and predicting and showing why things work a certain way and then showing your line of best fit. Machine learning is definitely more about here's a question, here's an answer, and how do I get there? And it doesn't matter as much, you know, how you get there as long as the model is working. That being said, it's not super useful to compare the two because at this point, statisticians are pretty invested in machine learning techniques, and obviously machine learning practitioners use statistics. So it's sort of like a theoretical applied distinction at this point, but just so you know it when you see it, essentially. So there are some major considerations with respect to it. Cost is obviously one, and the cost model is surprisingly complicated for these things, a lot of times because it doesn't know in advance how long it's going to run. It doesn't know how long it's going to take to optimize the data that it's looking for. And so you can control that, but obviously your models will be lower quality if you don't let it run the full distance. So on small data sets, it can be free. BigQuery provides 10 gigabytes of model processing per month. So basically that means the amount of data that it needs to iterate over in order to build the model. Typically, that's going to look something like the input data that you feed to the algorithm. But obviously, on the other side of this, people are spending millions of dollars a month doing machine learning models. And if you think about some of the giant problems that people are starting to tackle with this stuff, it kind of makes sense. At this point, we're starting to see kind of insane breakthroughs to my mind in terms of image generation and classification, text prediction and transformation, things like that have started to get really fascinating. And so BigQuery, I think BQML is sort of like the baby step into some of that stuff. Certainly, as you get more into this, you're going to want more control over what your models are producing, and you're going to want to understand them a little bit better. So speaking of the understanding part, ML practitioners tend to call that interpretability, which is basically when you run a model, can you explain why it's giving the results that it's giving? How does it work? So a really good example of this is, you guys may recall from Facebook a few years ago, they built an algorithm for machines to barter with each other. So basically it was just a test where two computers would attempt to exchange certain objects with each other, like hats and balls and so on. And so after they let this model run for a little while, they looked at what it was doing, and the machines were basically speaking to each other in, it was not English. It was essentially, like ball, 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 give hat, 3, 3, go. And the other machine would say ball, ball, go. And it didn't make any sense at all. And so there was a lot of media coverage at the time about how machines were learning their own language and they were going to take over and so on. But ultimately, what was really happening behind the scenes was that they didn't prioritize the idea that the machines should speak English to each other. Interpretability was not a primary consideration. So the scientists adjusted the model to account for that, and then they began using English because that's how it works. It's still, still programmed by humans. And so I think that's a big deal if you're trying to do something for your business, or you really need to understand why you're making a certain prediction. How interpretable is your model, and how do you understand how it's working? That's less important for things like image recognition and replacement and object detection, because if it's working, it's working. But certainly if you're using it to make business predictions, or you're going to try to buy stocks or something with it, you want to understand why it's recommending what it's recommending. Last and equally important is the ethical considerations around all of this. And I find it difficult to talk about these topics without at least raising this subject. So the quote below is from the ACM's Code of Conduct for Software Engineers, which is actually a really good read for people who are interested in kind of the professional practice of software engineering. But basically it talks about the idea that you should be contributing to the public good. And what I mean by that is there have been all kinds of ML models that have been put into practice and then produced results that were unfavorable, or were biased, or were recommending certain things without really knowing why. A really good example of that is the Amazon job, the resume reader, where it was prioritizing certain resumes very heavily over others. Basically, when you're doing machine learning, you have some responsibility to make sure that what it's predicting and what it's doing is something that is sensical, and that you understand why it's making those recommendations, and that you can agree or disagree with them. Machine learning can only look at the past. It's basically going to make predictions based on things that it's seeing. So if you're interested in changing the world, you have to move forward. You have to innovate on top of what it's telling you. And it may very well be showing you the world the way it is, but it's not necessarily the way you want the world to be. So I put that out there because it's very easy to kind of fall into that trap, and it's concerning, I think. I think it's become a big deal in the media, and for no other reason that your company will end up in the media, for that, it's worth looking into. And if you're interested in that, I strongly suggest you read the ACM Public Code of Conduct, and there's a ton of stuff on the internet around implicit bias in machine learning models and disparate impact and all kinds of interesting things. So let's talk a little bit about BQML models specifically. So there's two primary kinds of models. There's supervised and there's unsupervised. So a supervised model is one where you label the data and then you put it into the system, and then it trains based on the correct answers. So for some percentage of your data, you're going to say, here's the question, here's the answer that is, here's the correct answer, and then you figure out how to get there for the rest of the data. So typically you would use about 80% of your data in the training model, and then you would use 20% of that data, like 10 and 10, to test, to validate that model is working properly, and then you can show it data that it's never seen before. So the big difference there is that you already know the answer you're looking for, and you want the machine learning algorithm to be able to get there. So a really good example of that, we'll be doing a classification model, but when you do classification, you give it a bunch of classification answers. So you would say, for example, if it were trying to identify clothing, you would say, here are a bunch of shirts, here are a bunch of pants, here are the right answers for these things, and now here's some stuff you've never seen before, and what is it? And the fitness of the model will basically be determined on how it responds to that data. Unsupervised models are the opposite. You don't give it any labels at all, and it sort of figures out what the underlying patterns in the data are. So there are a lot of unsupervised models around prediction of clusters and building data into separate data sets and creating kind of averages. The primary unsupervised model in BQML is k-means, which we'll talk about in a second. So let's go into some of the model types that BQML supports, so you can understand what it's doing when you're using it. The number one, the primary model, is a regression model. So regression is essentially the same as statistical linear regression, if you're familiar with that. So you give it the label and you tell it what the correct answer for the question is, and then it creates the line of best fit across all of the different variables, which are called features, and then it tells you how well it did, and then it's able to predict against that. So an example of that for business would be something like prediction of sales. So given historical sales volume over certain periods of time, give me what the sales volume for next week will be. And it's able to figure out, based on looking at the data, which features are probably going to be relevant to that and weight them accordingly. And then interpretability with respect to regression is you can find out why it thought certain things were more important than others. So basically, it's going to be the same. It's regression to the mean line. But the big difference for the ML regression model is that it's going to use all of the variables, all of the coefficients available. You know, it can go into the thousands or millions of variables, depending on how much source data there is. Classification is basically answering yes/no questions or multi-answer questions. If you're familiar with the Silicon Valley episode where they identify hot dog or not hot dog, that's a classification model. What I think was really funny about that was when it aired, it was still, object detection of that kind was still a little bit out of the reach of most people, and now it's just, you know, fairly commonplace to do that sort of object detection. So classification models are actually just regression models, but they have a threshold with them, and then that threshold specifies, based on where it thinks the line lies, which side of the line to fall on. And so what I mean by that is that if you set your threshold to be, the threshold goes between 0 and 1. If you set it to 0, it's going to classify everything as 1. And if you set it to 1, it's going to classify everything as 0. So in addition to creating the regression line, you also will pick the threshold that works best for the kind of data you're looking at. Thresholds are important because sometimes you don't want false positives, and sometimes false positives are okay, but you don't want false negatives. It sort of depends on the kind of data that you're trying to extract. For example, if you're trying to do, for example, cancer diagnosis, you don't mind false positives that much as long as you're catching all the actual instances of cancer. Obviously, it would be better if the model were perfect and it got all positives and negatives correct, but you definitely would want to prioritize making sure that you caught everybody that was in the positive group, even if that meant a higher degree of false positives. But there are other models where you wouldn't want to do that, and so you would set your threshold differently. The variation of this, and the one that we'll be looking at shortly, is the multi-class classification, where instead of just yes or no, or 1 or 0, or 2 options, you have multiple options, and you're trying to take all of the source data and create the correct result data. And so again, you can do that with labeling your data. So you would say, you know, in addition to hot dogs, you have hamburgers, and whatever other kind of barbecue food. And then you could put all of those into classifications, and it would tell you it's a hot dog, or it's also a hamburger, or it's something else. And the joke, the Silicon Valley joke, is that it's not very useful to do binary classification on a single detected object, which is true. So you can also do the multi-class detection. The unsupervised model that BQML supports is called k-means, and k-means is really just what it sounds like. It calculates the mean of k segments. So you look at data that may or may not be clustered as well as this example, and you say, tell me what the natural clusters of this data look like and what are their averages. And the algorithm, you can tell it how many segments you want, or you can try to have it figure it out, and it will go and create the averages. So this is actually a fairly simple algorithm to do across a few variables, because you really are just finding, like, this is a two-dimensional version where you're finding the two-dimensional average, which is essentially the same as finding the minimum distance where all of the points are to their clusters, so like the minimum average. But as you get into, again, hundreds or thousands of variables, that gets a lot harder to do manually. And then lastly, as I mentioned, you can also do TensorFlow imports. So TensorFlow, if you're not familiar with it, is a Google machine learning package in Python. And it's very popular for data science. There are obviously other competing models at this point, but a lot of people still use TensorFlow. And if that's the model that your team is already using to do predictions, they can export it in a form that you can then load it into BQML directly. If you do this, you won't have the same level of interpretability from BQML because it doesn't know how the model was generated, but it certainly will unblock you if you are currently waiting for somebody to get back to you with some sort of data science team results.
Mark?
Yes.
So you were talking about the TensorFlow. Does that mean that your data goes to Google servers or leaving to Google servers?
Yeah, so your data will live in the BigQuery warehouse. Like, your data will live in the Google servers that are hosting BigQuery. It doesn't leave BigQuery. It doesn't leave the BigQuery world unless you're doing calls against federated sources. So you can also do, so that's the same as Redshift or Azure. Like, you can do calls across to data that you don't own, and you can run BQML across federated sources. I'm going to actually show an example. But your data will stay in BigQuery once it gets there.
Got it. And TensorFlow is essentially just a Google package, but is it calling web services of Google or no?
No, it's a standalone package.
Got it. Okay.
Yeah.
And does it require any licensing?
No, I don't know what the license is offhand. I know that it's open. It's open source, but I'm not sure what specifically it's licensed under.
Got it. For any of the attendees that joined, if you have any questions, drop them in the question box, and I'm going to voice it to Mark in different pieces, in different places in his presentation. Thank you, Mark.
Yep. So now, lastly, before we go into an actual example, I'm just going to go over a general methodology for how you generally will create and interact with a machine learning model. This is true kind of no matter how you're doing it. This is just a set of general steps that people will typically practice. So it's pretty basic. First, you do data analysis, which we'll go into, basically figure out how you're going to do it. Then you create the model, which historically, if you're doing it in Python, you spend a lot of time figuring out how to get the data into the model and how the model is going to work, and then you run it for some period of time. When it's finished, you evaluate it and you see how effective the model is, which depends on the kind of model you're making. And then once you're happy with it, you can start making predictions against it. So I'm going to go into this in a little bit of detail, and then we're going to do an actual example in BQML. So data analysis or exploratory data analysis is basically, hey, I have a data set and I want to find out something about it. What do I do? So there are a lot of ways you can do this. It's really similar to how classical data analysis works. You're going to split the data, look at the columns, see how clean the data is. If there are sparse populations of certain columns that you think you need, how many nulls there are, if there are unknown values, the ranges, that kind of thing. And basically what you're trying to get to is feature selection and extraction, which is sometimes called feature engineering. So the feature is, in BQML terminology, it's just going to be a column of your table or your view. The feature is the data point that you want to use in your machine learning generation. So one of the BQML examples that Google publishes is predicting baby birth rate or baby birth weight based on different factors. So you would figure out what are these features that I think are going to help me correlate the information to weight. And you're kind of guessing based on what you know about the data. So you would be able to say, well, maybe the height is going to be useful, or maybe the gender is going to be useful, or maybe the day of the year. I mean, they're going to be more and less helpful features. And the idea is to find the optimal set of features that get you the prediction that you're looking for. The more features you use, the longer the model is going to take to run, and the more expensive it's going to be. But sometimes you need a lot of features to predict. Feature extraction is taking multiple features and transforming them in some way to make them more useful. So a good example of just basic extraction is if you need to know something about somebody's age, you may not want every individual integer to be its own bucket. You may say, I care about this person's in their 40s, this person's in their 50s, and so on. And so you would create extra features that are based on data in the system. You might also create composite data where you care about combinations of certain two columns together, and you want to send all of those examples in. You might want to rescale your data if you're more concerned about the distribution than the actual data. Or you may actually be pulling data from entirely different sources and joining it in. So for example, something that's really popular in doing like e-commerce or logistics prediction is you look at how many items of a certain SKU that a store is going to sell in a day. And so for doing that, you may actually want to know things like traffic or weather or other unrelated data sets. So you're going to get interesting pieces of feature extraction that are going to help you predict. The other thing you're trying to do is you're trying to prevent what's known as data leakage. So basically the machine learning model is going to find patterns in the data. So if you inadvertently put data in there that reveals information about the target, then you may end up with a very good model that actually doesn't know anything. So the key example of that is a lot of times when people were doing clinical trials or doing basically manual data analysis and then putting it into a table, they would put all of the rows of one category at the top, and then they would put all of the rows of the other category at the bottom. And then somebody accidentally would send like the primary key, like send the ID into the model. And so the machine learning model would learn very quickly that anyone with a row ID of less than 53 had cancer, and anyone that was higher didn't. And it was 100% correct, but it doesn't mean anything because it's not supposed to have that data. So when that happens, you see something called overfitting, which means that you get, for instance, maybe like 100% correct results. It's always right. And that doesn't seem right to you because it shouldn't be able to be 100% accurate. And that's a pretty good indication that your data is overfitted. There are a lot of other subtle ways that leakage can happen. If features are in a ratio to each other, for example, like you want to predict how many dollars something is going to cost, and you accidentally send in how many euros that thing costs, it's going to figure out the exchange rate, and then it's just going to say, hey, I figured out that the answer is always 0.96 or whatever. And again, like you wouldn't know that information when you were trying to look at it on unseen data, so it's not helpful. So that's another thing you're trying to do during your exploration. Lastly, for BigQML specifically, you would generally want to federate your data or build a view or do something so that it's easier to manipulate that data. After you do that, you create the model. And creating the model is actually one SQL statement called create model. And then it will do additional transformation, load the model, and then it will train the model. and then it will give you the results. So we'll go into that pretty quickly. It's really easy in BQML. When it comes back, it tells you how the model did. It will give you statistics based on the model type that tell you how effective that model was. And from there, you want to look at how they were weighted. You want to look at whether it agrees with the kind of prediction you're trying to make, whether you can get the correct number of false positives or false negatives. Did you send the right features in? Does it look overfitted? And then you repeat the process. You add or remove features. You extract data from other features. You decide that your model probably, there's no way to make good predictions because you don't have enough information, and so on. And so you just repeat this process until you get what you want out of it. And then after that, you have a model in BigQuery that you can use to make predictions on. And it's basically like a function that you can call from that will create predicted values for whatever your target was in your model. And so once you have it there, it's accessible to every BigQuery system. So you can get it from the API, you can build cloud functions or serverless, you can build notebooks, so like Google Collaboratory, or there's all kinds of other notebook systems that you can access BigQuery from. You can also then tie it to real-time data analysis. So if you're doing streaming into your warehouse, you can write pre-processing that will actually look at the BQML model and create predictions as you go. So you can even do things like create reports and dashboards with your predictions on them, sort of in the stream, which is, it's pretty great if you get that up and running and you have people that understand the machine learning. So before I go into the example tutorial, are there any questions kind of on the background? Because from here on out, it's just going to be the applied example.
So far, I don't see any questions. Mark, perhaps maybe it would be a basic question, but does machine learning requires you to know what level of stats you need to know? I mean, can you basically get into machine learning field without knowing stats?
Yes, definitely for BQML, you can just create this and run it and see how effective it is and then just go with it. I think naturally as you start to do these things, you'll get more interested in the statistics and the interpretability. But the really nice thing about BQML is that it requires none of that. So the example that we'll do, like we won't really talk about any of this stuff other than to show the evaluation. I think it just comes down to how well do you want to be able to explain what it is that you're doing. And then as you want to start tweaking to get better results, that's when you would want to start having more of the advanced techniques. But you can definitely just go and do this without any idea what you're doing.
And without knowledge in stats, would you be able to, I guess, explain the result that you're getting, or it's going to be a problem?
Yeah, you can explain it. And I mean, definitely, like there are lots of measures. There are lots of ways to look at the effectiveness of models. Some are pretty basic, like accuracy, which is just how many predictions did it get right. And for things like that, like you're not going to need to know a whole lot. I think it's just when you want to start tuning, or certainly like if you have a very heavy important use case, like if you're going to do this for medical or something where people's lives are on the line, like then you would want to have the example. But if you just want to do basic prediction, like you can just run it. I think it's actually a really good way to get started because you don't have to get into it until you're ready to.
Got it. Thank you.
Yeah, and there are so many resources because this is so buzzy right now. There's just a ton of stuff out there, and you can get into it kind of as quickly as you want to. So while I'm on that subject, GCP has a crash course in machine learning that's really good. I think they say it will take about 15 hours, but you can skip through pieces of it. There's also a lot of really good documentation and examples for how this stuff works, and you can do all of that in SQL. So you don't have to get into the Python side of it at all to do this. So for people who are really good at SQL and are nervous about the other side, this is great. And honestly, like I found myself going right back to BQML when I was doing modeling in Python because I was like, I can think better in SQL. So it's great to have that option. So the example that I'll be going through in the remaining 15 minutes or so, is you guys may have seen, if you are interested in Harry Potter at all, like everybody likes making these quizzes about which house are you going to be in based on I don't know what, and you fill out a bunch of questions and then it tells you get sorted into a house. And so I was thinking like, well, why don't we just do machine learning, right? Like, why don't we just have it look at all of the data and figure out which house you're going to be in? That seems like it would be better than a random quiz. So like, honestly, I'm not a real big fan of this. You get labeled for life at 11. It's based on, I don't know what character traits, excuse me. But it's kind of, yeah.
Before I forget, so there is a question, and Mohsin is asking, I think I heard ML be done entirely using SQL in BigQuery. Does that mean that the entire end-to-end data science lifecycle can be executed with little to no Python?
Yep, that's what that means. Yeah, and we'll actually do it now.
Awesome.
And I won't do anything except SQL. I know last year's talk, I think I wrote like one line of SQL and people were like, it's SQL Saturday, you have to use SQL. So we're gonna do more SQL. There are at least 3 SQL statements in this talk. So just a background if you happen not to be familiar with Harry Potter, but it's an essentially just a classification algorithm. You take some information and then it tells you one of 4 answers. So I thought this is perfect, right? This does no bearing on anything whatsoever. If it gets everything wrong, no one's gonna die. Low pressure machine learning model, we can see how it does. So the way this is gonna work is we're gonna look at the existing data, which is a data set that I found on the web, actually a couple data sets that we joined together. We're gonna make a multi-class classification model against that data set, and we're gonna build some predictions. And we're gonna discover that your last name is a stronger predictor of which house you're gonna be in than any personality traits, and that science is way better than a random hat. So here we go. Okay, so just so you guys can see, this is the data set that I started with. It's actually in Google Sheets, which I learned you can do live against a BigQuery, which I actually learned for this talk. I didn't know you could do that. And this is just a bunch of information about Harry Potter characters. It has their gender, their role, where we know it, this will be the target label. So this is their house. So this is how we're going to predict people that don't have one. Information about the wand that they carry, a bunch of stuff about whether their hair color and their eye color, stuff that really shouldn't have any bearing on anything, and then birth date for all of that. And that's it. That's the only information that we're using in here. And so we'll follow the steps here, right? So the first thing I did was in the data exploration, I looked and saw what kind of data that there was available. There's actually a lot more data available. You can get all of the books and the scripts and who says what, but I was trying to make this as simple as possible. And I also wanted the model to be able to run like during the talk, because if it's going to take minutes, then you guys don't want to sit here and wait for that. So after I did the data analysis, I took a look at the data from Sheets and I imported the sheet directly into a BigQuery table. So if you look at this table, if you look at this houses table here, this is actually a federated data source directly from Google Sheets. And I'm not going to go into too much how you can do that. There's a blog post at the end that has some of this information in it. But basically, you create a new table and you give it a Google Sheets URL, and then it shows up as a table in BigQuery, which is great. There's no ACID for any of this though, so that's not great. So after that, I made a view, and basically I just took all of the default BigQuery names or default Google Sheets BigQuery column names, and I created a view, which is going to be the input view to the machine learning model. So this is just this will be just like a regular SQL table. You can see this is the statement I used to create the view, and if we select from the view, we'll see all this data, which is exactly the same data as what you were seeing in the sheets, except I've given it column names so that you can see where that information is. There's one additional piece of data, which is the frequency that the character appears in the books, which is useful because if they never show up in the book and they get predicted to be in a certain house, it may not mean anything. Honestly, none of this means anything. So after I did that, I made the view, and you can see this is the view here. The actual data science piece of this pipeline is as simple as creating the model. So the model creation statement that I settled on was here, and this is what it looks like. So you say you want to create the model, you provide a transform function, which is, you can just provide columns from your view. There are also a bunch of pre-processing functions that you can run here. I'll describe this in a second. And then you tell it what kind of model you want, and you tell it the target column. So I want to predict house, and I want to do that by using all of my data in my view table, where there isn't no house, like the model needs to know the house, so it excludes that other data. And I'm also excluding the IDs and the roles and the braces and everything, because those are overfitting problems. If you send it the ID and you tell it what the person does, it knows right away, so that's not very interesting. The last piece of this is this pre-processing function, which is a function that will, as I was mentioning before for age, it will create buckets over the distance that you're looking for. So in this case, it's 2. So it's basically going to say for this person's wand length, from 8 to 10 inches is a bucket, 10 to 12 is a bucket, and so on. And you can do that. There's other ones you can do. There's lots of scaling. There's other features you can do. And then after that, you run the statement. And I'm going to run it, and then it's going to take a little while. But as it's running, I'm going to do the cooking show thing, and I'm going to show you what it looks like when it's done. So at first, while it's running, you're going to see it pre-process. So that means it's taking all of the data and it's performing the transformations and it's loading it into features. So the thing to know about machine learning algorithms is that they're all numeric. So it has to transform anything that's like a string or an array or whatever. It has to transform that stuff into numeric form. So if you send it something with 6 examples, you're going to see it do 0.0, 1.0, and so on. You don't need to know any of that in order to do it, but that's what it's doing behind the scenes. And when it's done, which it's still training at the moment, but this is the previous iteration, you will see characteristics about it. And this is where you see how it did, basically. So you can see here that loss, which is basically how far away it fell from the correct answers, decreased over time. So it ran 7 iterations, and each time it ran a prediction, it got slightly better at predicting until the last iteration where it was losing very little data at all. This is a very good loss function. It's because this data is overfitted, essentially, as we'll see, because it's really easy for it to predict, and it does very well. So you'll see that in the training view. And then evaluation is where you're going to see, it literally just finished. So evaluation is where you're going to see how it did on everything. So again, like if you don't understand these statistics, like you can see what a lot of them do, but basically it's telling you how effective it was at predicting true positive, false positive, true negative, false negative, and then it's averaging over those different things. So I mentioned accuracy, which is just how many got the right label. So it got correct 99% of the time, which is like, it's a little concerning. It shouldn't do that well, essentially. And then precision is how many of the positive case was it actually positive, which for multi-classes, how many times did it predict something that was correct in the positive case? And then a lot of these other metrics, I would encourage you to look up some more. There's a little bit in the blog post as well. But basically you're looking to see, is my precision between 0 and 1, is it closer to 1? Is my recall closer to 1? Is my accuracy closer to 1? And then is my loss, which is the same as what we're looking at here, this training loss, is it close to 0? But again, this is all, the tooltips are pretty helpful, and there's a lot of good information in the documentation as well. So now we can see kind of the easy to read part of this, which is how many predictions did it get correct? And it did extremely well. It looks like it only missed a couple of people that it thought should be in Gryffindor, but actually belonged in Ravenclaw. But it got everything else correct. So definitely if I were doing a real world model and I saw this result, I would think something was wrong because it's too accurate. There wasn't a lot of data and it did extremely well. So that means probably there's something in the model that's leaking, or there's something that's giving away too much information. So I'll spoil the party. It's actually the person's last name. When you take the last name out, it gets significantly less predictive. So that means like there's some kind of weird caste system in Harry Potter and it's all terrible. That's how I would read it anyway. Okay, so after you look at the evaluation, the other thing you might do is you might look at the weighting. So this is where you would see which weights, like which columns, which features predicted and how positively or negatively they predicted for certain things. So if I run this weighting query, you can see I'm just pulling from a function called weights against the model that I created. And you can see for each class, it tells you based on the feature and the category what the weight of it was. So basically it's saying that if your hair is gray, you are very likely to be in Gryffindor. Again, that seems sort of biased. And there's a lot of similar information here based on all this other data. And you can see for the places where I made buckets, it just gave me the bin numbers and I'd have to go and look and see, but it's like 10 to 12 or 8 to 10. So any positive number means that it was correlated highly with the positive prediction, and a negative number means that it biased away from that prediction. And so you can review this and sort of understand, is this what I wanted? Are these the correct predictions, and so on. You could also ignore it and say, you know, everything's fine, I'm happy. So after you would do this a couple more times, which I will spare you running the model over and over again, but you would basically go and look at that model statement again, and you would say, I don't like what I got here. I think this should probably be out of it. I don't want this anymore. I don't want this. And you would go ahead and change these and rerun the model. And you could also have it predict something else if you wanted to. But you know, this is, for this example, we just want to predict the house. So once you're finished with all of that process and you're happy with the evaluation for the model, the last step is to do prediction. And a prediction is also just a function based on a system that you understand from SQL. And in this case, it's a function called ML predict. And ML predict takes the model that you created and it takes a SQL statement from where you want to do the prediction from. So we're just going to feed the view right back into the prediction, which will let us do two things. One, it will show us our accurate predictions because it will show us the actual house and then it will show what we predicted. And two, we're just going to run it on all of the data from the books where we don't know the person's house. So if you look at this, there's all kinds of characters down here. We have no idea what house they belong in. So it's going to go ahead and create houses for all of those based on the model. And because it's pulling from Google Sheets, you can actually go and create new characters at the bottom of this sheet and fill in this information, and then it will give you predictions. So it's not like a really cool UI Sporkle quiz, but it's pretty darn accurate. So, you know, you could go ahead and make some kind of BuzzFeed page on this and then be popular. No, you would not be popular. So then running this prediction, I just ran this query. You can see the prediction is really pretty fast. It only took 2.5 seconds to run across this whole table. And you can see it is now creating predictions for characters that do not have houses in the books. Of note, it has sorted Steve into Gryffindor, which I think is probably accurate. So I consider that to be a success. There's a couple of other interesting choices here. And then below that, you can see all of the correct examples that it made for all of the predictions where it was accurate. And it was accurate in pretty much every case, except for this one, which is the one we saw on the matrix before. I actually don't remember who this character is or why it would get it wrong, but it got it wrong. And then everything else it got right. So moral of the story here is basically if you have a last name where your family goes into a certain Harry Potter house, you'll probably go into that house too, which is, I guess, not that surprising. If you remove name from the model, then it gets significantly less predictive, but it still does fairly well. So you can definitely like copy these queries. There's a link at the end of this presentation to that, and you can run it yourself. These numbers are very small here, like we're only using kilobytes of data, so you don't have to worry about like this is all going to be free tier stuff. So conclusion, yeah. So to the question, we did a whole data science pipeline, albeit a simple one, entirely in SQL. Like that was all there is to it. Like it's literally just writing those input and prediction queries. We didn't look a whole lot at the math. Like I think it's helpful to know that we did a supervised multi-class classification algorithm, but you can do all of that stuff anyway. There's definitely a scale limit to BQML as far as, I mean, it's not like a performance scale, but it's as you want to start tuning or getting more complex or getting into other kinds of models, you'll probably want to jump into something a little bit more advanced, but you can't beat this for just really simple creation. And that's pretty much it. So please fill out a session evaluation if you like the session. And then this presentation will be available, but there's also a blog post that is related to this. And that blog post has all of the code examples that I used. It also has the source data set, so you can replicate this on your own pretty easily. And that's all I got.
We have a few minutes. Any questions? Mark, what do you think if I can unmute all? Think it's a good idea?
I don't know if it's a good idea, but go for it.
Okay, let's try it. Okay. Oh, I clicked on unmute all, and it doesn't do it. Maybe it thinks it's a bad idea.
That's the same problem we've had in testing.
You were talking about BigQuery and GCP. What's the basically minimum buy-in in dollar amounts? I mean, can you, let's say, run everything for free to some degree?
This you can run for free. So when you sign up, they give you a $300 one-year credit, which actually covers a good deal more than the free tier. BigQuery free tier is, I forget what it is. It's like a terabyte a month in data access, and you can do maybe a terabyte in storage. Don't quote me on that. I should know this, but I can't remember. And then, as I mentioned, you get 10 gigabytes of model prediction. So this would all be free tier. There are other more advanced machine learning platforms on GCP, and some of those are not. Some of those do not have a free tier, but they mostly do have a free trial. So you can get pretty far on this. But everything we did today, if you make an account on GCP and you enable the BigQuery API, like this will all fall under free tier.
Got it. So there is a question from Hussein asking, thanks, that was informative. Does BigQuery have all complex formulas like pandas, numbers, and such?
No, it doesn't bring you all the way to what you can do with pandas data frames, and it doesn't get you everything into. It's not quite as robust, but it has everything on the SQL side. So if you're familiar with analytic functions in SQL, you can replicate most of that same behavior using SQL. And it's interesting, like they're very parallel systems. They do a lot of the same things, but the approach is pretty different. And I sort of see this as one of the steps towards unifying those two worlds. And then as you get better at jumping back and forth between the two, you can choose whether you'd want to do analysis with like Python packages, or R has a lot of this too, or you'd want to do it in BQML or SQL.
So what would be the way to bring pandas and other stuff?
So kind of out of scope, but there's I think what the best way to look that up is. I wrote about it, but I don't have any blog posts up about it yet. So if you use Jupyter notebooks, so either Google Collaboratory or Kaggle has them, or you can build your own local, you can integrate the BigQuery SDK into a notebook, and then you can call it with Python magic. So you can do BigQuery select statements directly from inside a notebook, and then it'll create a pandas data frame directly from that. and you can do your analysis there. You actually can do both inside the notebook, which is actually, it's pretty easy, but you have to then be fairly familiar with kind of how data science notebooks work first. But yeah, you can totally integrate the two.
Got it. Do you have any slide by any chance, or maybe you don't want to share it, how to contact you?
Yeah, I don't have it in here. My email address is in my webinar control panel. You just do on the fly. Just type my email here. It's just my name @gmail.com. And certainly if you have any other questions, feel free to contact me. My LinkedIn is also earlier in the slide deck. So if you get a copy of the slide deck, you can do it that way too. But I'd love to take any questions you guys have.
And by the way, the slide deck is already on SQL Survey.
Cool.
I think you did it yesterday, or maybe a few days before.
Yep.
You mentioned about free 14-15 hour online training to get started in ML. Can you please give some details?
Yes, so I can just do this here too. It's called Google GCP Machine Learning Crash Course. And it's right here. So this is the link. It's a developer Google's Machine Learning Crash Course. And it gives you kind of a whole sort of self-paced tutorial with some video training. But it goes over all of the stuff we covered today in a great amount more detail. And then it will give you kind of what you need to do stuff inside ML. And then this isn't specifically about BQML, but it will, all the concepts will cross over.
Thank you, Mark. Thanks to everyone that joined Mark's session.